I will walk you through the 5 steps I take at the beginning of every data science project to kick off EDA or exploratory data analysis. I've been working as a data scientist at Brown University since 2015. I became a part-time instructor in 2019 and an assistant professor in 2021. I worked on over 20 different machine learning projects, and I teach data science to more than 50 graduate students each year. My students sometimes call me Professor András. Whether you have received very little direction from your boss, or you are unsure where to start in the sea of summary statistics or potential figures you can prepare, it's natural to feel daunted, but I'm here to help. I will walk through each of the 5 steps, and I will illustrate each of them with code. The first question you need to ask yourself is whether you know what is in your dataset. Every dataset you work with should come with a very detailed description. Let me show you a great example. In this video, we will work with the Kaggle house price dataset, which contains roughly 1500 rows and 80 columns, which means we have information on roughly 1500 houses, and each house is described by 80 different variables. This could be the number of bedrooms, the square footage, the number of bathrooms, whether it has a pool, etc., etc. The dataset comes with a description, which you can see on the screen. And this description contains one paragraph of each column in the dataset. And that paragraph describes everything you need to know about that feature. This is a rather long text file because we have 80 columns, but it is definitely worthwhile to read through it and make sure you understand everything in your dataset. If you do not have such an excellent dataset description, you need to start by creating one. Open your database with Excel or your favorite programming language, collect all the column names, list them in an empty text file, and write one paragraph for each column. Fortunately, data scientists rarely work alone, so there should be a subject matter expert on your team who is able to answer any of your questions. Each column belongs to one of 3 main feature types. It's important to know the type of each column because that will determine how you will prepare the dataset for machine learning models. I will go through the 3 different feature types and how you can identify them. Stick around until the end because the last one is the trickiest. Continuous features typically contain integer numbers or floats, and they describe some sort of physical quantity in a specific unit of measurement. For instance, they might describe time-related quantities such as time spent on a website, flight duration, or the age of a person. In these cases, the units could be seconds, minutes, hours, days, weeks, months, or even years. Continuous features can also describe distance-related quantities, such as the height of a person, distance driven or flown, or the size of a tumor. Some units could be inches, feet, miles, centimeters, meters, or kilometers. It's very important to understand the nature of the quantity described and the unit of measurement. You need to collect this information and include it in your description. Categorical features typically consist of strings, and each string describes a unique category or label. These labels are independent of each other, and there is no inherent ordering amongst them. Examples of categorical features include maybe the home state, home country, sex, race, different airline companies, or car brands. To properly handle categorical features, it's very important to collect all unique categories, their meanings, and document it. Okay, here is the tricky one, ordinal features. Ordinal features lie somewhere between categorical and continuous features. They also contain labels similar to categorical features. However, those labels can be ordered or ranked in some meaningful way. Educational level is an ordinal feature because someone who completed a bachelor's degree ranks higher than someone else who only had a high school diploma. Salary ranges, different descriptions of quality such as bad, average, good, excellent, or star reviews are also examples of ordinal features. Unfortunately, ordinal features can be represented by strings or integer numbers as well, so it's very important to properly identify them. Collect each unique category, their meanings, how they can be ordered, and document all of this information in your description. How many rows and columns are there in your dataset? Or in other words, how many data points do you work with and how many features are used to describe each of your data points? I will show you a few lines of code how you can figure this one out. So we open our Jupyter notebook and in the first cell, I import two packages. First one is the pandas package, which is often used to deal with tabular datasets. And the second one is matplotlib. This is the visualization package, and we will prepare some figures later on in this video. In the second cell, first I read in the CSV file using pandas read CSV function into a data frame called df. And in this line, I print out the head of the data frame, which will show us the first 5 rows and some of the columns of this dataset. You see that the first column is an ID, and I drop this ID column because the unique ID does not contain any relevant information for our machine learning models, so we might as well just drop it. In the next cell, I print out the shape of the data frame. If you run this cell, you will see we have 1460 data points and 80 columns in this data frame. This may seem like a trivial question, but it's surprising how many practitioners don't know the answer. The size of your dataset will have an impact on the machine learning pipeline you develop, so it's very important to know this information. For example, if you have a large number of features, but only a small amount of points, which is pretty typical in genomics, for example, you might have to do feature selection before you train a machine learning model, and you might be limited to use machine learning models which can deal with such a dataset, for example, tree-based techniques. Other extreme, if you have a large number of data points and only a small number of features, you might be better off using simpler machine learning models, such as linear models or k-nearest neighbors. If you work on a supervised machine learning problem, you will have a target variable, a quantity that you are trying to predict. Identify which column in your dataset is your target variable, and then you can determine what type of supervised machine learning problem you are working on. If your target variable is continuous, you have a regression problem. If your target variable is categorical, that will be a classification problem. And if your target variable is ordinal, then you might have a ranking or some sort of mix between classification and regression. Once you identify your target variable, calculate some simple summary statistics and also visualize your target variable. I will show you how to do this using pandas. So we are in the next cell of the Jupyter notebook. In the first 2 lines, I separate out the feature matrix and the target variable. The target variable is going to be y, and it will contain the sale price column of our data frame. The goal in this dataset is to predict the sale price of the houses. So this is going to be our target variable. Our feature matrix is x, which contains all the other columns except the sale price. Then I apply .describe on our target variable, which will give us some summary statistics. We will see the mean of the feature, the standard deviation of the feature, the minimum 25th percentile, 50th percentile, 75th percentile, and the maximum value within this feature. The last few lines in this notebook, I create a histogram to visualize the target variable. This is the final figure. We plot the house price in units of US dollars on the x-axis. We plot the count on the y-axis, and I also added a title for this figure. Stay tuned until the end of the video to figure out how you can engage with the material in a deeper level. Most datasets will contain missing values, so it's very important to identify them so we can deal with them appropriately. Be cautious, because missing values can be represented in various different ways. Most often, they will be represented as NaNs, not a number, but sometimes they will take on peculiar values. For example, if your feature is age, missing values in the age could be represented by a weird number like -999. It's a great idea to collect which of your features contain missing values, what fraction of the features are missing, and what fraction of your data points contain missing values in at least one of the features. I will illustrate with code how to solve this task. So in these 3 lines, I calculate the fraction of missing values in the features, and I print out the columns where this fraction is larger than 0. Let me run this cell. You see that these are the features that contain missing values in this dataset. The lot frontage feature contains roughly 80% missing values. The alley feature, 94% of the values are missing, etc., etc. In the last two lines of this cell, I calculate what fraction of the data points contain missing values in at least one of the features. If you scroll down, you will see that in this dataset, all points contain some missing values. We have already examined the target variable closely. Now it's time to take a look at each of the features. You can iterate through the columns, and you can use the .describe or .valueCounts methods based on the data type. This will provide you with the basic summary statistics of each feature, such as the mean, standard deviation, or in categorical features, you will know the unique categories and how frequently each category appears in the column. Let me demonstrate with code how you can accomplish this. So we are in the last cell of the notebook, and first I collect the data types of each column and then apply the pandas unique function on it, which will tell us the unique data types we have in this feature matrix X. You will see up here that we have columns that contain integer numbers. We have columns that contain strings. This is the object data type. And we have columns that contain floating point numbers. Then I start a simple for loop, and we loop through each column in the dataset. I print out the column name, and if the column type is an object, I will apply the .valueCounts method on it. If it's not an object, it means it's an integer or float, and in that case, I will apply the .describe method. If you scroll down to the output of the cell, this is a rather lengthy output, because we will have some information on each of the 79 features that we have in this dataset. But remember, these 5 steps only scratch the surface of EDA. There is so much more you can do. Make sure to keep an eye out for my upcoming video, where I will describe one of the biggest EDA mistakes I have made. That's a lesson you don't want to miss. Don't forget to check out the video description as well. I included a link to a public GitHub repository where you can access the Jupyter notebook I walked through in this video. So make sure to take advantage of that resource.